Rajeev Vaisakh in the Physics PhD program. Rajeev's presentation is Probing the Cosmic Expansion in Nearby and Distant Universe.
You all must have seen a clear night sky and wondered how beautiful these moons, the stars, and the galaxies look like. But there are countless galaxies far, far away that are drifting away from each other each second as I speak. This is what we call the expansion of the universe. Well, how can we understand it? Let's suppose this universe was a balloon, and all the galaxies that we know of are like tiny coins embedded on these balloons. So as the universe expands like a balloon, the galaxies or these coins don't change in size, but then the distance between them keep on increasing. This is what we call expansion of the universe. And now I can't blame the universe expansion for my increasing wasteland. But then, what causes this expansion? That's still a mystery. So there's this mysterious entity called dark energy that accounts for more than 2/3 of our universe. And it doesn't interact with anything. Well, to put things into perspective, the matter that you, me, all the objects here are made of just account for just 5% of this universe energy expenditure. Well, if something doesn't interact, how do we study it? We study its effects on a global scale. So here is where my research comes into picture. With the help of the dark energy spectroscopic instrument, I tried to study how these objects are clustered in this universe by creating a 3D map of all these far-off galaxies. Well, think of an object like a prism. Light enters it, and it gets split into its constituent colors. We pick one color or one light, and then we study its properties by relating it with the composition of a galaxy. This is exactly what DESI does. And instead of one such object, we have 5,000 fibers, and that are robotic, so it means more accurate. And we study it by getting data from these far-off galaxies. So how do we measure it? Imagine that a train is approaching us. As it approaches us, we hear a higher pitch, and as it goes from us, we hear a lower pitch. This lower pitch means that the sound wave associated with it is stretched. Similarly, far-off galaxies have a stretched light wave. Using this, DESI creates a 3D map of this universe. And like you can see in the bottom right, each object here is a galaxy. So far, we have only found 400,000, and we are still about to find 30 million galaxies like this to understand how our universe is expanding. Thank you.